Hello everyone, it's December 11th. Alright, let's do this. Alright, let's do this. Count mentions per user. You are given an integer number of users, representing the total number of users and an array events of size n by 3. Each event I can be either of the following two types. Each event can be either of the following two types. Message event. This event indicates that a set of users was mentioned in a message at start timestamp. Okay. The message string can contain one of the following tokens. ID number, where number is an integer in a range. There can be multiple IDs separated by a single white space and may contain duplicates. This can mention even the offline users. All users. Here mention all online users. Message, okay, and then offline event, offline timestamp ID. This event indicates that user ID I had become offline at the timestamp. For 60 time units, the user will automatically be online again at timestamp plus 60. Return an array mentions, where mentions I represents the number of mentions the user with ID I has across all message events. All users are initially online, and if a user goes offline or comes back online, there are status changes processed before handling any message event that occurs at the same timestamp. Now that a user can be mentioned multiple times in a single message event, and each mention should be counted separately. We have to go through some examples. I generally have an idea of what the requirement is. Alright, we have two users. Here are the events. So we have a message happen at 10. Oh, are they sorted or no? Hold on. Number of users, events. Int is this. Between 1 and 100 because we have 100 users. Guarantee the user ID reference in the offline event is online at the time of the event occurs. Okay, so mentioned 1 and 0, and then 0 get offline at 11, and then at 71 only mention online, but after 60 it get back online, 0 get back online, so 1 get mentioned once and 0 get mentioned once. So a few things I want to understand. First, are they sorted? Yeah, we don't have an example, so we're gonna create our own example. So basically, let's put this at the end. Okay. Put this at the beginning. Yeah, I think you have to sort them. You have to turn this into. Can the timestamp be overlapping? I bet it can. I can put all three at the same timestamp. Yep. You can put all three at the same timestamp. Okay. So when this happens, when it goes offline, at the same timestamp as mentioned, so when you have this, these just get mentioned regardless. So these we can actually ignore because it doesn't matter if you're online or offline. So they all get mentioned once. And then at time 10, it get offline. But I also mention all online people. Right? I also mention all online people. So this means we'll handle the message, or always handle message first, and then handle offline. And then when I get back online, we will handle the online first, and then handle the message. Because otherwise you won't be able to get 1 and 2. Right? So hold on. So 0 get mentioned once, that means it goes offline first. So this here doesn't get mentioned, right? 0 doesn't get mentioned. Only 1 get mentioned twice. Okay. So we always handle offline, online first, and then handle the message. Oh yeah, it says goes offline or comes back online. Their status change is processed before anything. All right, so we can go through everything. Get rid of all of these. If it's not here, so mention all users, which means if it's all, it doesn't really matter. So if I do all, then they all get mentioned, which is going to be 2 and 2, even if it goes offline. Yeah, and that means if I get offline even earlier, if I get like offline earlier, that still is going to be 2 and 2. Timestamp will start at 1. Yeah, okay, so all the actual mention, these are, you don't have to worry about them. The only thing you need to worry about is here, right? The only thing to worry about, so you're going to collect a bunch of offlines, and you're going to collect a bunch of offlines, collect a bunch of a bunch of here, and you're going to create a so how about this? We create a here array. Okay, so it comes from 0 all the way to the time. What's the maximum time? Maximum time is 10 to the 5th. Let's do 10 to the 5th. Okay, so 10 to the 5th. This is here. How many times here is called? And then we're gonna get the offline. Okay, offline. Can someone get offline twice? I don't know. Can I call this offline twice? I mean, if you offline twice, I don't think it oh, I think it says guarantee the user ID referenced is online at the time of event occurs, because it's already offline, so you cannot call offline again. Okay, so that's a guarantee that it will exist. So we will not have to consider that scenario. Okay. Then what we need is a timeline, right? But at a time, you can have multiple people getting offline, right? But you won't have the same people getting offline at the same time. So maybe, right? Maybe what we can do is offline is also going to be an array, but it's going to be an array of array. In here, we'll have the ID, right? We're going to have the ID of all the people that gets offline at that time. So what we do is we will go through this. So we'll go through everything. We collect all the others, and then we collect here at different times how many times here is called, right? How many times here is called. And then what we need to figure out is at that time when here is called, how many people are online, right? We need to know how many people are online. Which means we will go one by one here, because this is a time. So we at a time, right? We find out that these people are offline, which means in the next 60 seconds, 60 ticks, these people are not online, right? These people are not online, which means if there's a here call, then these people cannot be included, or you can say they must be excluded, right? They must be excluded. So what we can do actually is include all of them first, right? Include all of them first, and then we go through here, and then we just remove, right? We remove the mention of those people. So let's say we have an ID of some people here, and then within the next 60 ticks, so we can maintain an array of offline people that's currently offline. So when we hit this, we put people that's currently offline in here. That could be a set, right? We put people offline ID in here, and then we move on to the next tick, and then we check if there's a here call. If there is a here call, then how do you know how old they are? How do you know how old they are? We need a timestamp. So we need a priority queue here. I'm trying to see if it's possible without using priority queue. We don't have to, because this, when we push in, we can push in ID and the time, right? And then it's going to be array, another ID and a time, right? It's going to be an array. Every time we hit, we just extend, and when I have a new timestamp, right? When new timestamp, we compare with the first to see if it's within 60 seconds, and if there's a here call, then we'll remove this from the count, right? And if it's larger than 60, then we will just delete this, right? We'll just delete this. Okay, and they say the state change happens first, which means if you hit a timestamp that has a here, and then you added this, right? You added this. So we'll just if this is the same, right? Because we have a timestamp. The current timestamp, these people are offline, and if I hit this, you have to remove. And if the timestamp is 60, okay, yeah, I think this will work. I think this will work, but might take some time to actually code it up. So what we're gonna do, first of all, say there's 3, 4, 3, 3. We don't have to worry about the message that contains all or individual IDs, because the person, the people, right, will be mentioned regardless whether they are online or offline. Thus, we only need to keep track of the here and offline messages. Go to sleep. All right. We only need to keep track of here and offline. We will increment for everyone on all the here calls, here messages. Then we will go through offline messages, and we'll go through offline messages and remove and remove the people that are actually offline for a given timestamp. I think it's gonna cost this. All right, so I need a and a number of users, a number of events. What's the timestamp? We don't know. I need a timestamp. I have 100 event. Timestamp is 10 to the 5th, which I don't know. So I'll just go 10 to the 5th. Hmm, 10 to the 5th. Maybe a map is easier in this case. Maybe a map is easier. And I'll just go tick one by one. But with a timeout. That's actually a good point. So if we don't do it that way, right? If we don't do it that way, then we have to do the here, right? Instead of remove, we'll have to go to first tick when the person is not there, right? And then we check if there's a here call. And then for each here call, we have to include yeah, we have these here call, right? And then we'll increment everybody. And then I see these people at this timestamp is off. So we'll go through from here to here, 60 seconds, right? 60 seconds. 60 seconds. I want to know how many here calls. Maybe a prefix sum. Maybe a prefix sum on here. Right, so I know from this to this how many here calls in this 60 seconds, right? Then I just remove all of them for this person. Maybe, okay, maybe, yeah. So we only need to keep track. We'll increment for everyone all the here message. We will use a prefix sum to keep track the number of here messages in any given time span. Okay, so max time. So we say, okay, we need a int result. It's going to be member users. Prefix here. Okay, as a prefix here. Events. I need to sort them. Right, so here events, here timestamps, here times. Okay. What else? And we also need Oh, I'm saying we're using a map. This is offline people. Okay. Now we say for E of events Alright, so we have message type. Alright, so type E0 T timestamp Right, the second is timestamp. Third is depends. Third is it could be an ID or it could be this. So it can be here or all. Right? Oh, offline. Offline has to be just a single ID. Okay. Offline is single ID. So we just say if type is equal to offline, then we say offline people T at this time set up pushback this. Okay, else, so the type is message. Then we got timestamp and a mention string, and then we say if mention string. Okay. Actually, I don't like it. Actually, let's just go E0. And then E2 go to here. Else if E2 equal to all. Okay, else. So if it's here, then we'll add, but here timestamp. So here timestamp, here timestamp stop pushback T. All right, because it's a here, we mentioned a here, and we can do, yeah, we push it back T, and then we have to add everybody. We say for int I equal to 0, I smaller than number of non-users, I plus plus, then res I plus plus. That's all. Then for int I 0, I smaller than number plus res I plus plus. Right. What else? So now is if it's not, then we can split. Actually, I don't know how to do split. Split string by delimiter. String.split. vector. Huh, there's no split. Jeez. Alright, we'll probably use this one. Find yeah, we need a separate function for this. I would do this one. Parse IDs. I know token. Huh, what is token? Oh, it's a get line. I need to save this. This is actually not right. I want integer. So I'll get line this, getting the token, this, res pushback, token, substring, position, 1, 2, 3. Right, should be 3, 0, 1, no, 2. It's ID, right? We have ID. ID something. So 0, 1, 2. Start from 2 towards the end. And this is going to be S2I. And then we'll return res. Okay. And then else we say for int ID of parse IDs E2. Okay, let's just not do const. Let's just do a copy, it's fine. Okay, for this, what do we do? This is the IDs. So we need to say offline. Right, offline people. It's a map. T. No, it's not offline people. This is a mention. This is a mention. It should be res ID plus plus. Okay, so now we go through this and we need to map is already sorted. What we want is std sort here timestamp stop begin here and okay, then we need to do a prefix sum. Right, we're gonna do a prefix sum basically. And it has that prefix sum. Do we want to do prefix sum though? So we have timestamp when the here is mentioned. Maybe we can binary search, it's easier. Right? We can binary search. The here timestamps is from small to large when here is mentioned. And you're gonna go through the offline people. So when you go to the first offline people, all those people are gonna be offline from this timestamp until the plus 60, right? So what you're gonna do is find in this range how many here has been triggered, right? So that is essentially a binary search. Yeah, I think binary search will suffice. We don't need a prefix sum, right? So we will use a binary search to find the number of here messages in any given time span. So we have this, and then we just need to say for I don't know how, I forgot how to iterate through map. It is const auto, I think that should be, yeah, const auto. Const auto offline t and IDs, right, of offline people. Okay, so I have t, we have IDs. So t will be used to get low and a high. So we say auto low it, right? Low it will be, I'll say lower bound here timestamp stop begin, here timestamp stop end, and t, right? This is lower bound is the first one that is not bigger, right? That is not bigger than this value, which is smaller equal to. So we'll find the first one that's so, but they are offline at this time, which means what? First one that's not smaller, right? That's lower bound. It's like a lower bound. The first one that's not smaller. Yeah, first one is not smaller. So basically the lower bound point to the here that we need to remove. And then we'll have auto high it, right? So we go to upper bound. Upper bound here timestamp dot begin, here timestamp dot end, t plus 60, right? It's a higher bound, it's larger. The first one that's larger, which means you need to do a higher bound. This it minus 1, that is smaller because your plus 60 is the time that they give back, and they get back first, so you don't remove that. But the one before, you do remove that. So the distance, right? So we say number of heres shall be the distance from low it, right, to high it. So low it to high it. So low it is inclusive, high it is not inclusive. So the number in the middle, I think that is the number of heres. And then we say for int I of IDs, res I will be minus equal to num heres. And then we'll return res. I'm not sure, that did pretty fast. It's actually not trivial at all. Oh, I cannot. Maybe I do one. Well, we go through most of it, but the first one is wrong. I got 1. Okay. So offline, I report at time 11, we have a 0, right? So basically we have offline at time 11, we have a 0. And then now message doesn't matter, we just like add 1, so 71. So we also have is a here timestamp. So here timestamp is 71. And then the answer right now is 22. Okay. Then we go through all the events. Now I already go through all the events. So here is going to be 71. So we're gonna go through the offline people. And we have the T, right? T is 11. And then lower bound is gonna be this, pointing to this. Upper bound is pointing to end. And then the distance from this to this is 1. So the here is called at that, right? Which means this one should not be included. Which means I think if I do 59, because at 60, if you have something matching, it will automatically move to the second one. And then the 60 will be part of the 60 will be part of the removal, but we don't want it to be removal. Use 59 seconds to ensure that if a here call, if a here message happens at the same time as a person goes back online, we do not remove the mention. All right, let's see if it works. That works. Actually, it's not O(n) squared. It's O(n) log n. Or something. O(n) squared because you have to get you have to do this part. This is O(n) squared. Events times this. You know what? O(n) squared is fair. O(n) squared is fair. Okay, so that's that. It actually took a while. It's 44 minutes. But it's actually a good question, I think. Complex enough. Playback after sorting. Yeah, it's gonna be complex one way or another. Did they use binary search for this? I don't think so. I don't know what they use. They sort. Yeah. Next online, yeah, they keep track of the online, next online time. Oh, they keep track of the next online time for everybody. Fair. That's fair. That's fair. I see what they're doing. They have a next online. So every time you get somebody who's offline, you plus 60, that's when they're going to be online, next online time. And yeah. Yeah, it works. All right.